Hi, everyone, and good morning, good afternoon. Thank you so much for joining today's webinar, Long Duration Energy Storage in America, the Bridge to a Clean Economy, sorry. My name is Christina Galan, and I will be your moderating today from ATA Insights. Thank you, as I said, joining. We have a chat available for you to introduce yourselves, tell us where you're from, your job title, where you come from, and why long duration energy storage is interesting for you. We have a great panel today. Thank you so much, Caroline, Gabe, Madeline, and Daniel. Well, Dan, sorry, for coming today. We hope everyone enjoys the session. We have a couple of housekeeping rules before we start, which is the session is going to be recorded, and we will be sharing it with everyone in a couple of days. Also, you have the chat available also for the people who are joining from YouTube, and for the people who are joining from Zoom, you have a Q&A section below. So if you have any questions for our panelists, please remember to there's a Q&A section which we'll be answering after the presentations. So the flow of the session will be, we have each expert have a couple of minutes of presentation talking about different things in their field of expertise. And then we have a couple of pre-submitted sessions followed by pre-submitted questions, followed by some questions from our people attending. So without further ado, I would like to introduce Gabe Murtaugh from the LDES Council. Gabe, good morning. Can you hear us?
Hello. Yes, I can.
Right.
How are you?
Very good. How are you? Where are you connecting from?
I am connecting from California. So
Okay.
It's 9 o'clock in the morning here. So definitely morning for me.
Okay.
Yeah, right outside of Sacramento.
Great. All right. Well, whenever you're ready, Gabe, if you can share your slides, see if we can see them perfectly.
What we can do here. Okay. How's
Perfect.
that?
All good.
All right. Well, welcome everyone. I'm glad you're here today, and I'll be watching time as well. So I know we've got 10 minutes just for this opening session. But long duration energy storage is incredibly important, and it is a critical piece of how we decarbonize energy industries and industrial applications. So this is very timely that we're having this discussion, and I'm glad you all could be here to participate today. My name is Gabe Murtaugh. I'm the Director of Markets and Technology, and I work for the Long Duration Energy Storage Council, or the LDES Council. We are let me see here. Yeah, we are an organization that has about 70 members. Most of those members on the left-hand side of the screen are technology providers. So these are actually companies that are thinking about long-duration energy storage and have a solution. Some of those solutions are in various levels of development. Some are quite far along and sort of ready for prime time. Others are kind of just getting started. We also have some anchor members. These are probably more familiar names, folks like Microsoft and Google, Sumitomo. These are folks who are thinking about how to use long-duration energy storage in typically some aspect of their operations. And then we do have a couple of capital providers, and we have one service provider as a member as well. Slide. Always have to think here. Just a little bit of eye candy here. These are some of the technologies. Some of them are renderings of technologies, but some of them are actually pictures of installed capacity, but what some of these storage resources may look like. Obviously, there's a whole variety of different kinds of long duration energy storage and different use cases, different sizes, how different functions and how they work. Specifically, we usually break down long duration energy storage into 4 different types. So there's mechanical long duration energy storage, thermal storage, chemical storage, and electrochemical storage. Starting from the bottom and working up, electrochemical, we're usually thinking about, we sometimes joke and say, well, this is any 2 elements off of the periodic table, but you're thinking about how those 2 elements react together to separate electrons or gather electrons. Chemical is kind of interesting because you're thinking about solutions like hydrogen. Hydrogen is obviously something that's been talked about for a long time. There's a lot of potential there. The other interesting thing about storing energy is hydrogen. You could clearly take electricity, turn it into hydrogen using an electrolyzer, and then you could potentially burn that energy or burn that hydrogen to create energy again and put it back on the grid. But you can also do other things with hydrogen. You can power like a city's bus fleet, or you can put hydrogen into cars to burn. So there's other in-use applications for chemical. There's also other in-use applications for thermal as well. So thermal energy storage is taking electricity, turning it into heat. And of course, you could use that heat to generate steam, and then you could use the steam to generate electricity. Or you could potentially also use that thermal energy in other downstream applications. So food and beverage manufacturing, chemical manufacturing, things like that are all applications that are very heat intensive. And there's technologies out there that can be used directly in those applications and charge effectively from energy from the grid. There's also mechanical solutions. These are probably the oldest batteries that are on the grid today, and certainly the most prolific kinds of long-duration energy storage on the grid today. Pumped hydro is an example of a mechanical solution. There's gravity-based solutions, there's compressed air solutions, and then there's variations on those technologies as well. A lot of those technologies have been around for a while, but there's a lot of really smart people coming up with new ways to utilize those technologies. So that's very exciting. This is another graph, and this is interesting information. And I don't know, maybe after I'm done, maybe you'll give information about if we're sharing these slides, because hopefully we are. Lots of good stuff here, and it's all captured in various ways on the Long Duration Energy Storage website, which I would encourage you to check out and look at some of our publications there. But I think this is one of the most essential charts that we have. And it basically says on the y-axis, the vertical axis, how far along in terms of development are some of these technologies. And then on the x-axis, on the horizontal axis, we're thinking about typically for these kinds of solutions, what sort of durations are we looking at? And you can see some of the solutions are very short duration. Maybe their sweet spot is in between 6 hours, 10 hours, 24 hours. But some of them have longer durations. You're thinking about the 20-hour solutions, the 100-hour solutions, and the 100+ hour solutions, where you can really take this energy off the grid and store it for a very long period of time. And then obviously on the vertical axis, some of these resources, pumped hydro storage, like I was just talking about, has been around for a very long time, definitely a mature technology. There are a lot of long duration energy storage technologies that are ready for prime time. There are sensible heat solutions out there. There's contracts that are being inked, and these are being introduced and put online. Flow batteries, advanced compressed air, metal anode. So there's a lot of ideas out there and things that are ready to go. And then there's a few that are kind of waiting in the wings, that are pre-commercial, and then in the demonstration phases as well. Why are we all here? Why are we talking about this just in general? The International Energy Administration has suggested that the world can still limit global warming to less than 1.5 degrees Celsius. But in order to do that, we need to triple installed renewable resources by 2030. You can kind of see what that means in the graph on the right. But if you think about how long it's taken us to build all the solar and wind that we've got on our system today, the challenges that we have with interconnections, the challenges sometimes we have with supply chain issues, things like that, this can be a really daunting task. And at the same time, we have to continue to increase electricity efficiency, roughly double that from 2022 to 2030, and then obviously continue to increase electrification. So really lofty goals. But what does it mean if we're tripling installed renewable resources and we're relying more on those renewable resources? Well, if you add more and more and more solar, that's going to help you address load during the solar hours of the day when the sun's up. But during other hours of the day, the evening hours, your peak ramping periods, it may not help you very much. So storage is going to be a really critical component of this decarbonization effort. This is another graph from the IEA, and I've actually included a link here on the bottom of the screen as well. But you can see, and this isn't terribly surprising, there's two lines towards the top of the graph at the 2010 time frame, and the brown bar, or the brown line, is coal, the purple line is natural gas. You can see that over the next 10, 20, 30 years, we're really expecting a big ramp down in terms of how much energy we're getting from those sources. And then you can see in 2010, on the lower portion of that graph, there's a blue line, a light blue line, and kind of like a copper colored line. And they're sort of like jumping up off the page into 2030, 2040, 2050. And that's obviously the solar generation and the wind generation. So we're expecting to get a lot more energy from those sources, just like we said in the last slide. So what does this actually look like once you install these things? So New York has goals to fully decarbonize by 2035. So 2030 is sort of a midpoint along in that target. There's been some analysis that has been done, and this is actually, full modeled analysis on what the grid is going to look like in 2030 and potential resource mixes in 2030. And you can see there's two different graphs here. The graph on the top includes storage of all durations. The graph on the bottom only includes storage with short durations. The thing that I would point out that's really important on the bottom graph is you see all that area in the really bright red at the top of the graph. Those are periods when you've sort of overbuilt your solar and your wind because you need it for certain times of the day and certain times of the year. And you can't capture that energy from storage resources because you just don't have enough duration. The graph on the top shows how much energy is effectively clipped or curtailed from your solar and wind fleet if you've built both short duration resources and long duration resources, and it shows that you're more effectively utilizing your resources. The economics behind that say that, if New York doesn't consider long duration energy storage, by 2030, you're already missing out on about $1 billion in revenue per year. So these numbers really do add up. Same thing in California. This is looking a little further into the future. This is in 2045. What am I going to do with some of those very, very long duration resources? Exactly what you might expect. You're going to charge these things up in the spring and the fall. You're going to discharge these in the summer and the winter. And what's interesting in the California grid is that the winter becomes the most constrained period because we're going to be relying on solar energy for most of the energy that's consumed by customers, and obviously solar is less abundant in the winter than the summer. So some kind of interesting findings there. And then you've kind of got the same kind of numbers. If you are going to drive down to 0 million metric tons of greenhouse gas emissions by 2045, what do the costs look like on the far left in that 2045 bar for no long duration energy storage versus the cost with long duration energy storage? Well, you're saving about $6 billion a year by considering long duration energy storage. So really big numbers, really impactful in terms of how you're actually going to get to decarbonizing grids. Final slide here, and I think I'm right at 10 minutes, which is kind of a miracle. You can feel free to reach out to me if you just want to talk about decarbonization, if you want to know more about long duration energy storage. I've also included 3 of these US-based studies. So some information about how California is decarbonizing, where those graphs came from, some information from New York, and then there's been a really recent study that just came out on New England, how you decarbonize and what long duration energy storage looks like in those scenarios. So I'd encourage you to keep reading, keep learning about long duration energy storage. It's definitely what we need for that bridge to the future when we're decarbonizing.
All right. Well, thank you so much, Gabe, for this introduction and the explanation, which is extremely interesting because there's a lot to learn. There's tons of stuff out there. So thank you for starting the panel. And what better way to continue it with some technologies that we have here that we can learn from. So we're going to start with Madeline Frierson from MALTA. Hi, Madeline. Good morning for you because you're in the States as well.
Yeah, good morning. Joining today from Atlanta, Georgia.
All right.
It should be pulling up now, so let me know if
you
can see it.
Perfect. In the meantime, just wanted to let everyone know that we will share with you the presentations in a couple of days with the recording as well. So you will have that available, I think, in around 2 to 3 days, but definitely this week. So thank you, Madeline. Sorry for the interruption. Whenever you're ready.
Not a problem. Hi, everyone. My name is Madeline Frierson. I'm part of the business development team with MALTA. I'm excited to be here with all of you today. Gabe just gave a great introduction of long duration energy storage, what's available from a technology standpoint, and really why do we need these technologies. So figured it's a good time. I'll give a quick introduction today of MALTA's technology. I'm going to keep it very high level, so feel free to reach out to me directly. I'm happy. We can get engineers on the phone. We can go into as much technical depth as you'd like, but I'll keep it very high level. So we're here today to talk long duration energy storage, and that's fitting. It's exactly where MALTA sits. As Gabe mentioned, there is a wide array of different technology types when it comes to long duration. And each of these technology types are going to be suited to different use cases. MALTA is a type of thermal energy storage, which means that it stores energy in the form of heat. We do this by storing energy across a temperature differential using molten salt as the hot medium and methanol as the cold medium. We can take energy from the grid or directly from a renewable source, store that energy in the form of heat, and then release that energy when needed in the form of both electricity and heat. We see ourselves as a grid scale solution, which means that our technology performs best at these types of larger scales, 50 megawatts, 100 megawatts. But as a company, as a technology, we're exploring kind of a variety of use cases and potential sizes. So one of the distinguishing characteristics of thermal storage is there's often an additional heat output that Gabe mentioned, and you can see it very simply outlined here in the diagram. In MALTA's case, we do have a heat output during the discharge process that can be used for a wide variety of industrial applications. For instance, if it's located nearby a paper mill, an agricultural site, any type of industrial process that requires heat, we can route that off-take heat to the industrial process, which adds not only an additional revenue stream for the plant, but also further supports the decarbonization efforts of the industry. Similarly, you could use it for district heating purposes. We've explored that use case in Europe as well as Canada. And our temperature output, as you can see here, it says 120 degrees Celsius, but that temperature can be adjusted to meet project needs. As you learn more about thermal energy storage, you'll see there are technologies that serve more of the higher heat range, the medium and the low. So there's really places for multiple technologies to serve these different use cases and these different temperature profiles. So I'm not going to go into too much detail about how long duration energy storage as a class of technologies is enabling the energy transition, but I'll point out a number of elements specific to MALTA's technology and other technologies like it. So we offer a like-for-like replacement to thermal assets that provide both firm and flexible capacity with our ability to ramp and load follow, and to provide the long duration capability to address the vast majority of grid needs. And this is all done without concerns of cycling-related degradations capacity, so grid operators have the freedom to operate the resource as a load-following asset. Our solution poses low technical risk, with the main innovation really coming from the integration of proven components and equipments. There's no real new chemistries here. There's no new systems that haven't been validated before. It's really the innovation is from the integration of these systems. Our solutions is quickly scalable to hundreds of megawatts, thousands of megawatt hours by relying on existing supply chains from our OEM partners with deployment readiness of commercial scale plants within the next 3 years. And one thing to know is you'll see this photo, it's familiar. It looks and feels a lot like a traditional thermal plant. And in reality, the skills required to operate and maintain a MALTA plant have significant overlap with those required to operate an existing thermal plant, such as natural gas or coal, which really helps ease the workforce transition as we transition to a greener grid. And really quick, I'll just provide a very quick history of MALTA as a company. So the concept behind the MALTA system was first identified by a Nobel Award-winning professor at Stanford. And that concept was then acquired by Google and run through X, the Moonshot Factory, which is actually Google's innovation lab. It graduated from that program in 2018, and we've been a standalone company ever since. I have a number of blue chip investors. I won't read them off here. And then we really rely on our partnership model. So you'll see here Alfa Laval, Siemens Energy. Siemens Energy is now an investor as well. And we really leverage the really strong engineering engineering efforts from these companies, and really see ourselves as partners with them. And then the system has been validated a number of times by third company parties such as Bechtel, who has performed their own independent technical diligence to validate the technology. And happy to kind of go into more detail with anyone or would like to see some of the outcomes of those reports. I'm happy to do so. So as I previously touched on, the components in the MALTA system, salt, air, cement, steel, are already being utilized at scale, very low risk, non-toxic. We don't need to build any factories out as we're leveraging existing heat exchanger and machinery technology. So we're really ready to deploy at an expedited scale. So for the last several years, we've really been in the stage of validating and very small pilots. So now we really see ourselves as a deployment ready because those supply chains are up and running. And finally, the MALTA plant, as I said before, has the familiarity of a typical power plant. So we talk about 100 megawatt, 10-hour duration a lot of times, and that requires, just for context, about 12 acres of land, but it's very customizable. You can put an L shape based on the land availability, and there's no geographic limitations for the MALTA plant. It can be located urban, rural, on brown or green fields, and the duration's very easily scalable, which I think is a big advantage, just by adding additional. So you'll see here the molten and the methanol tanks. So in order to increase the duration, you just have to increase the volume of the methanol. So a customer, if at this point they're looking at, they only need 8 hours, 10 hours, but in the future with the increase of renewable penetration, they see they're going to need 20, 40, 50. Later on, they can always add more methanol and molten salt as we go on. So I could go into more detail on technical depth, but for now I'm going to keep it kind of really brief, so we can get to questions and kind of really get into the meat of this conversation. But please, if you have any questions at all or want to go into more technical depth, I'm happy to go through that with you, and feel free to reach out. Thanks.
Okay, thank you. Thank you so much, Madeline, for this approach and a really curious start of MALTA. I didn't know about that. So thank you also for getting this technology a little bit closer to us. I see that Gabe is working a lot on the questions. So that's great. Just a clarification for the Q&As. We're looking for questions. The comments are great, but better in the chat, so we can move on directly to the questions that you have. Meanwhile, we are going to move to another technology with Caroline. Hi, Caroline. Good morning from BASF. Great to have you again. Really looking forward to know more about your technology. So whenever you're ready.
Let me unmute. We'll do that first. And then let me try to share my screen. Okay, and I'm gonna start at the beginning. Can you see the first slide?
Yes, but it's not on presentation mode. I think you're using the other one.
Okay, it's
One second.
being a little difficult here, so let me.
It's okay. We can start again.
Yeah, screen
It
sharing.
happens.
So let me try this one more time. My settings. Swap. Any better?
Nope. Don't see anything. Are you sharing something now?
I am. And it's not doing it.
I don't see it.
Okay. Anything there? Nope.
No. Can you stop sharing and share again?
I will certainly try.
Perfect.
I promise we practice this, guys.
It always happens. It happens to me all the time.
Let me share this again. Now let me try to go into the presentation mode from here.
Okay.
This one?
Perfect.
Beautiful. Okay. Thank you so much for the support. Okay, so here we are. I am Caroline Branock. I appreciate you sticking around for the presentation. Yeah, from wherever you are in your virtual world. I'm calling in from Boulder today, lovely Colorado. Lots of sunshine here, so happy day. Let's talk a little bit about long duration energy storage, right? My background's in chemistry, always been working on sustainable product lines and now into energy storage. And I think, we're all here because we want a safe and reliable, energy storage an asset that will last 20 years and, be affordable and do all of these things for us. And let's see what we can get, right? I mean, this is what we talk about and this is what we dream of. And this is what BASF wanted, actually, right? And so this is what they were in search of, and they started to invest in it, right? Because they have very aggressive net zero targets and emission goals themselves, right? They have this global network of manufacturing, and they're looking at how do we achieve our goals, and not only how do we achieve our goals, but how do we help our customers, 80,000 strong, achieve their sustainability targets, right? So they decided to invest in energy storage. And they found it really helpful, not only for their facilities, but they decided to innovate around it and then offer it to the external market as well, right? So let's look at kind of this process, right? Insulators, right? And NGK developed over 20 years ago, and they started, installing on a commercial scale. So they have a lot of in-field data, and it checks a lot of these boxes, right, that we were looking for. It's, commercial scale, it's been around forever, it is safe, right? It's low fire risk because it's sodium and not lithium. So it's doing a lot of these things, right? And this is what, the holy grail that we were all hoping for, right? So they really started to invest in it. Look at ways to improve it. How do we get that RTE, that round trip efficiency up? How do we improve degradation? And this is kind of, the perfect union here. And they really started to look at it. Okay, so what is, and what is it not? What is this sodium sulfur technology? And I want to make sure that I talk with Gabe afterwards to make sure it's represented on all his charts and we're in the right boxes, which, by the way, that's an awesome chart. I love that. Because it's really important to make sure, everybody understands. Okay, okay, perfect. All right, so it's not MALTA, right? We are not going to be able to get you through 8 days. I think that was right, Madeline. This is going to be your 6-hour discharge duration, right? So think 6 hours plus, maybe 6 hours to 12 hours, depending on what you need for your application, right? So if you're talking 24/7 microgrid, if you want, maybe it's C&I applications in a city or in a remote location, right, to provide power there. It's a very versatile technology, which is really good because it can cover a wide variety of use cases. This is an attractive thing that we need from these long duration technologies. Okay, so it does check the 20-year plus box, right? We needed something that was going to stick around. It's not going to, 10 years and we're done and it's fallen apart and maybe the company doesn't exist anymore, right? So I think we've all kind of been there in this energy transition. So, this is something that's really important, and we, are very conservative. We've been around for 150 plus years company, wanted to make sure that this is something that we were buying as well as investing in for the long term. So, safety is one of our, core values. So is this a safe technology? Are we installing this in a safe way? Is it from a chemical raw material standpoint, is it safe? Yes, in comparison to a lot of technologies, right? When we're talking, I don't want to point out any, but when you're talking in comparison to other metals, other things that you can ways to store energy, this is a very safe technology. Sodium, sulfur combined, it's relatively safe. I think you'll also be pretty impressed. I was pretty impressed with the energy density of this, and we'll talk a little bit more about it, some of the innovations they've made in terms of the containerized solution, right? And the ability to double stack these containers. I think that's pretty attractive and creative. So, but I've got a picture of it in a slide. So let's try to find that. All right, so this is kind of for all you engineers in the audience out there. You know, what's inside the container? You know, let's open it up, tear it apart, and put it back together. You're going to find a 20-foot shipping container, right? So you can put it on a ship, put it on a truck, and then put it on a crane and drop it onto a concrete slab. So it's an easy install, which is attractive. Inside, you've got 6 modules that contain cells, right? These cells are going to kind of want to charge up over 6 hours. So it is not your Tesla fast charger, right? It likes to be like a daily cycle, if you will. C rate of 1/6, operating times of 290 to 360. So it's going to run hot. What you want to think about is the container itself. It's going to provide 250 kilowatts, 1.45 megawatt hours. Remember, you double stack, and they typically come in groups of 4, right? So you're going to see these out there on the field. They're going to be in little quads, right? 4 by 4 by 4. Okay. Important thing to remember, a quad, 1 megawatt, 5.8 megawatt hours, right? So if that's helpful, these are your important numbers. Quad, 1 megawatt, 5.8 megawatt hours. Okay. Right. Again, we alluded to this earlier, but these are your use cases, right? Can we take out these diesel generators and get some more carbon credits, right? What are your KPIs? What do you need energy storage for? Do you need grid stabilization or grid support or renewable stabilization? You know, are we doing a time of use shift? Are we trying to, you know, sell back to the grid so that we can make a little extra profit on this to offset our CapEx? What is important to you? I think this is one of the things that we found attractive about this technology is that it's very versatile. You can use it for backup as well as, you know, this day-to-day cycle, right? I mean, it's kind of like an airplane. I like to think about it like that. Doesn't make any money unless it's flying, right? So use it every day, cycle it daily. That's your most economical use of these storage devices, right? All right. I'm almost done. I just hit my 10-minute mark. I set my timer.
You're fine, Caroline. It's okay.
All right. But this is actually one of the questions we always get. And it's like, fantastic. The best thing since sliced bread. Why haven't I heard of it? And why isn't it in every city in the US and in every backyard? And I say, well, I think this graph or this map really shows an accurate picture or tells a good story. Remember at the first of this, I said, you know, BASF partnered with NGK probably about 4 or 5 years ago, right? The dots on here, the little orange dots, actually represent the NGK installations of the sodium sulfur technology, right? And there's a huge cluster over here, if you can see my pointer, in Japan of like 400 megawatts plus, right? So they really focused on the installations in Japan and that region, right? You can see now that BASF is partnering and they're working on this together. This is the stars are the installations since that time, and those are starting to broaden. And I think that gives me hope for the technology as, you know, really kind of sticking around and lasting in the future, is that it's catching on across the globe, which I think is a really good sign. Another milestone that's that looks very promising is we're looking at 4.9 gigawatt hours across 250 projects deployed globally. This is huge for the long duration space, right? We're talking about a lot of, you know, in Gabe's presentation, the early stage, right? we're just at kind of startup or pilot. I mean, this has been in the field for 20 years and they're still running, right? I mean, these are the kind of things that we don't see very often, and I think is really, really important. So what do you remember? 6 hours plus. If you're looking for something that's low risk, right? It's been in the field for 20 years. You're not taking a chance on something. You want a company that's going to be around. You know, we've made it 150 years. You know, fingers crossed they make it a 150 more, right? I think these are the things that you have to ask yourself. Do you want a technology that's not very price sensitive, that's going to fluctuate every year because it's based on raw materials that are, you know, rare earth or metals that fluctuate frequently? You know, those are the kind of things that I like to look down the road 5 to 10 years. Which technology will make it, and do you want to be there? Just some questions to ask and think about for the market. So thank you so much for your time. Looking forward to your questions. I'll try to keep up, and thank you again.
Thanks, Caroline, for showcasing BASF technology. And yes, you do have a lot of questions. People are interested in knowing more. It's great to have seen this technology, because not every technology is different and has a different purpose. So it's great to have these two models which are different, and we can get a little bit a better insight of what long duration storage means. So thank you so much, Caroline, for that presentation. Moving on to Dan Finn-Foley from PA Consulting. Hi, Dan. How are you today?
Doing well. Thank you so much for having me. I'll go ahead and share my screen.
Sure.
Let me know if you can see that there.
Perfect.
Wonderful. Thank you so much. Once again, Dan Finn-Foley with PA Consulting. It's great when webinar conversations sort of skew directly into what you want to talk about, as we've been talking about the technologies surrounding long duration storage, the need, the applications. There's so much room with all of these various niches for different durations, different use cases that require residual heat, safety constraints. There really is a massive opportunity, and that's what I sort of wanted to highlight quickly before we get into the great questions that people have been asking as well. So, quick introduction on my end. I'm Dan Finn-Foley once again with PA Consulting. We're an advisor for the clean energy transition. PA is an international consultancy with more than 4,000 experts. Our U.S. energy market and utility advisory team is about 125 people, where we focus on market modeling, investment, business transformation, M&A and advisory, a lot of different topics. We have experts that are focused on energy markets, utilities, and as you can see, we've had a pretty much national footprint in some of the projects that we've been working on, from an investment, sell side, market entry, strategic support element. On the energy storage side in particular, we've had several engagements where we've supported investment and market entry into long duration energy storage in particular, looking at supporting individual projects, strategic acquisitions, buy-side support, et cetera. So as part of this process, we've had a real wide-angle lens in terms of the long-duration energy storage market, and have been able to build out what I hope are some insights for the webinar here. So backing up a little bit, providing a bit of a technology-agnostic perspective on long-duration storage. The question of its potential really does come down to need. What is the need for the long-duration storage? And then how are markets, policies, other players, and customers recognizing the value that long-duration storage is providing? So as others have mentioned, we do sort of segment this market into various levels of duration, all of which are going to require different technologies, different solutions with different priorities. For the challenge of these kind of multi-hour renewable drought events, where you have, let's say, large amounts of solar penetration that then you need to shift into the evening hours, you're looking at something like 6 to 10 hours of long duration storage. This is exceeding the conventional energy storage that we have on the grid now, which was unconventional only 5 or 7 years ago, which is generally lithium-ion technology. But simply that technology does not scale as well as many long duration storage technologies, making a huge opportunity for all these various technologies that are represented on the panel here as well. This can provide grid backup, 6 to 10 hours for outage events, or for renewable drought events where you need that solar power to be shifted, wind energy, other systems as well. Then as you begin to scale up the duration need, you begin to look at these multi-day renewable and reliability events. This could be islanding a system to have backup capabilities. Winter Storm Uri is a great example of that down in Texas. Up here in the Northeast, we had really bad winter temperatures last winter. So far, not this year, we'll see. And then as these decarbonization targets get to higher levels, with 30, 20, 30, 40% renewable penetration, there isn't as much need for long duration energy storage. But as you get to 80%, 90%, 100%, the duration need to firm those last 5 or 10% or even 30 or 40% of renewable penetration really scales up dramatically. So this is where we have this 24 plus hour long duration storage need, which is really going to require some sort of solution to shift large amounts of energy over much longer periods of time. And then beyond that, you get into seasonal shifting as well, where you have, as Gabe mentioned, and Madeline and Caroline as well, these sort of multiple seasonality issues where you have more resources available during one month or season than another, shifting that through long duration storage, whether it's hydrogen, compressed air, pumped hydro, any of these sort of longer duration systems, but generally speaking, ones that are going to be shifting things on a much longer duration. So you can see that there's an entire spectrum here. And the reason that I want to highlight the spectrum is because from a look at the market potential, you will be hitting these different duration needs at different times, depending on the policy landscape, depending on the economic factors, market factors, other technological needs that may exist as well. So at PA, we've sort of created this long-term storage potential heat map for where we see the long duration storage potential evolving. Hawaii is one of the key areas, sort of what's canary in the coal mine, but in a good way. I haven't been able to figure out a good analogy for that yet. But as we've seen in Hawaii, where you have large amounts of renewable energy, once you get up to that 60, 70, 80%, you start to see this need for 6, 8, 10 hours of storage, which is what they're now installing now. Within PA, we see that need transitioning very rapidly into some of these leading markets. So this would be California, New York, areas with aggressive decarbonization targets and incentives to back those up as well. Targets and requirements that have real teeth and that we see resulting in significant scale deployments. These markets are also regions where there are actually direct callouts for long duration storage in utility resource planning, or even just studies on the need for the technology, as Gabe highlighted in his presentation as well. So this is kind of the class 4 states where we're really going to see a lot of this market potential evolve very quickly. But there are a number of follow-on markets that are going to be emerging quite rapidly, even as these move into place. And those are the ones highlighted in dark blue here, where a combination of utility needs, system reliability needs, renewable penetration increases due to economics and utility or state level targets. All of these are going to start cascading down from the late 2020s into the 2030s and start requiring 6, 10, 24 hours of energy storage quite quickly. And as a result, we're already seeing utilities engaging in pilot programs, a lot of installations and interest happening in these markets. But each of these is different and unique, which is what's going to make this such an interesting technological landscape and solution landscape moving forward. The solutions that are going to be prevalent in California, where there's going to be a lot of solar penetration, maybe Arizona as well, that are going to require shifting from one period during the day to the other, are probably going to look very different from something in the Northeast, where there's a similar renewable energy goal and support, but a lot of that is going to be met by offshore wind, a resource that might have day or even week-long resource droughts. You may see 8, 10, 12 hours of long duration storage in California meeting a lot of the needs in the system that aren't going to be met in New York or Massachusetts, where you start to see energy storage needs of 10, 24, 100 hours, even seasonal needs in order to meet those aggressive 100% renewable energy targets. So there's been a lot of investment in this space. There's been a lot of interest from infrastructure funds, major conglomerates, and then developers, technology companies, utilities. Really exciting time to be in the market. So if you'd like to discuss it more with us, I put our contact information here, so when you get the slides, you will be able to look through this. We'd be happy to discuss the market in more detail, hear about your view on it, your solutions, or see how we can support. So with that, I want to stop and make sure that we leave plenty of time for questions. Thanks so much.
Thanks, Dan. So where are you connecting from? Where are you right now?
Cloudy Providence, Rhode Island today.
Oh, wow. So we've got every part of the states almost covered. So that's great. So thank you, Dan. Thank you for that presentation and showing us a little bit more how long duration storage is happening, because it's something that's starting to happen, and we're happy to have everyone on board now. So we're going to move on to the Q&A section. We have a couple of minutes for that. So thank you all our presenters for being careful with your time. So I'm going to start with one from West Boston that Gabe wanted to answer, because I think it's a great one to start the Q&A section, which is if Gabe can define exactly what long duration energy storage means, because I know that there's been a little bit of questions there, how many hours, if there's a specific time frame, if you can talk a little bit about that, Gabe.
If anyone can do it, Gabe can, right?
Right.
I can.
Well, Wes actually teed up in his question the answer from the Department of Energy, which is also our answer, which is pretty commonly the answer, which is 10 hours plus is long duration. There are certainly, needs for, and some of the research that I was pointing to in my slide decks for even longer durations than that, but anything 10 plus is what we consider long duration.
And I can just say that subjectively, if you ask what long duration energy storage was 10 years ago, you would have the answer of anything longer than 30 minutes. And so
Very
now
different
we're starting
answer.
to think about things, up to 10 hours plus, but 6 to 8 hours is still highly outside the norm today. And that would be, if you asked somebody deploying things, that would be long duration. So these definitions are just going to be shifting year by year.
Perfect. Well, thank you so much for that clarification. All right, well, I'm going to continue with another one that Gabe wanted to answer, and it's if can LDES exist without any subsidy support today, which I think it's a great dialogue to talk a little bit about the subsidies out there and financial options, we would say.
Yeah, and this isn't, this is kind of a tough question. So I like it, and I think it's a good one to kind of sink our teeth into. But typically, if economics are dictating that something is worthwhile or there's profit to be made, you see those kinds of resources and technologies being built. As I was mentioning in some of my earlier slides, there are some technologies, long duration technologies, that are further along in the development curve. And typically, the way that they got there is by starting off small. You're building some test projects, some demo projects. Usually, there are funds available for that sort of thing. And I know there's a lot of governments, state governments here in the U.S., federal governments from the Department of Energy in the United States. And then there's a lot of other governments around the world who are funding kind of these early starter incubator beta projects, so that there is kind of liftoff in the technology. And then once you get technology established, you often do see declining costs, and that's what we're anticipating for long duration energy storage. So be on the lookout for that. And of course, as things get cheaper, then they become more economic, and you build more of them. So it is a bit of a cycle that you'll see us entering into. On the other hand, there are projects today that are being built, and some of these actually do pan out without any kind of other assistance. I think the one thing that I always note and caveat is that if you're not trying to decarbonize, if you're okay with emitting, greenhouse gases, then sort of all this goes out the window. Building a new resource, building storage resources, long duration storage included, it's expensive, it costs money, retrofitting your grid to accommodate these resources. That doesn't come for free. So if you are in a mindset of, hey, we want to decarbonize, we want to do it as cost effectively as possible, long duration energy storage is going to be in your mix. If you're saying, gee, I don't mind using natural gas fired resources, that might be a little bit of a different conversation. But one other thing I would just point out is that we put out a report on our website about cost effectiveness of replacing like remote coal operations with renewable resources and long duration energy storage. And those numbers actually are panning out. So, trucking diesel is very expensive, but because it is so expensive, retrofitting all of your mining equipment to be electrified, retrofitting your vehicles that you're using for mining operations to be electrified, and then using renewable resources is actually less expensive. So we are finding from some of our members who are investing in mines that this is something that they're opting to do just because the math works out.
Perfect. Well, thank you. Does anyone else want to add something regarding Madeline? I see you unmute. Go ahead.
I think Gabe summed it up all really well. I think one of the key things is we talk about these technologies that are ready to they've been doing the small pilot and now we're ready to scale up. A lot of times we talk about that first grid scale, first of a kind project. There's that missing money gap. And that's that gap that first of a kind grants, some of these subsidies, some of these different programs out there are really trying to fill, because the barrier for that first of project when it comes to financing, expensive, getting guarantees, insurance, performance, all of those. Once you have the first operation, you have some of validated operation characteristics, a lot of that barrier gets dropped, but it's that, and then a lot of times they are economical without some of these subsidies we're talking about, but getting that first grid scale project for a lot of technologies, I think that's the hurdle that these subsidies, grants are trying to help overcome.
Okay, great. Well, thank you for that intervention, Madeline. So I'm going to move on to Carolyn, where they're in the Q&A section. Thank you, everyone, for all these questions. We have tons of them. We'll be sending them to our speakers because people are really interested in knowing more. Carolyn, there's a question about if there are any limitations or restrictions to deploy NAS batteries, and if you can talk a little bit more about this aspect.
Yeah, so restrictions to deployment, I would say, there was another question that I saw scrolling through the Q&A.
You can go ahead and answer them without.
No.
Okay.
I mean, it was somewhat related. So thank you for kind of combining them for me. I think that's more efficient. This is going to be more focused on utility scale. I think someone was asking about, what are the long-term residential options? This is really going to be a little overkill. Somebody asked me the other day, oh, well, do you have one of these in your backyard? Well, I live in Boulder, so no, my backyard is not shipping container size, so no. It would supply my entire condo building, but not the typical residential setup. So I would say we're going to be focused more on residential utility scales. It will be appropriate more for that industrial. Some commercial operations, I do think we'll start to see more of this, where backup power becomes really important, whether it's with hospitals or industries that really need, especially for niche applications, right? Where they can't afford. I don't know if there are many manufacturers out there, but how many, what's the cost for 6 hours of downtime while your power went out and you can't figure out why or how to get it back up? That can't happen, at least not too many times. And so, we really want to look at that. But then again, limitations, we're not going to be able to cover the Texas freeze, for instance, right? This is not within our scope. But this is a hybrid solution. So we're going to look at, what could we work with to be a good solution for your application. So yeah, I hope that answered the question.
Perfect. Well, thank you. We're going to move on to another question that Gabe requested to talk about, and it's about hydro utility. 97% of all electricity. We are facing a drought. What technology would you recommend?
So this, I like this question a lot, maybe not so much for the specifics of this question, but for the kind of questions that we need to be asking ourselves at various points in how we're planning our decarbonization. So I think the first thing that you're pointing out is, and I think we're all aware of this, weather is getting more extreme. We're having more hot weather, we're having more droughts, we're having more cold weather. It's sort of all getting worse, and every year it seems like we're setting more and more records. What that means is traditionally the way we've done grid planning is we go back and we look at a 30-year historical look of weather, and we use those 30 years to make forecasts about what we think weather is going to look like in the next, say, 5 years or 10 years, something like that. And that doesn't, and time again, that's shown to not be very effective at predicting some of these extreme cases, because 30 years ago, 20 years ago even, we weren't having as much of this extreme weather. So you've got a lot of data that isn't representative of what's coming in our future. So I think we could be a little bit more sophisticated about our grid planning. And I think that's going to help us figure out, how we're going to get to decarbonization if that's what our goals are. The second thing that I would add to that answer is we also need to be very proactive about actually doing the model. This isn't something that you can figure out on the back of a napkin. It's not something that you can kind of guess at, say, oh, hey, yeah, it seems like solar's inexpensive. Let's just build some solar. Let's build a little bit of wind. The way that you get the least cost solution for decarbonization is to run a full-blown model of what your network looks like, what you're anticipating and how you're anticipating those loads changing over time. We did, at the beginning of my presentation, I talked about increased electrification. What does that look like for your area? What does it look like if you do have extreme weather? How do you plan for that? And then the idea is that you're not guessing at what kind of resources you need to be sufficient and reliable. Your model is telling you what you need to develop. And then from there, you can think about a strategy for how you move from the resource mix that you have today to the resource mix that you want to have for a reliable future. And I think, it's certainly easy to say, but the work and actually doing this and applying this is difficult. But it's what we need to do to actually, make the plans and to decarbonize. But it's a really nice question.
Perfect. Well, thank you, Gabe. One of my last questions goes to Dan. And Dan, how do you see the landscape evolving in the next 5 to 10 years?
Wow, so do we have another hour that I can go into?
You have 3 minutes. Does that work?
I'll try to do it in one. Over the next 5 to 10 years, you will see increased commercialization, piloting, and testing of emerging technologies. These will be focused on proof of concept for very long duration storage, 24 hours, 100 hours, and commercialization and execution of shorter long duration storage. Boy, that sounds silly to say, on the 6 to 10 hour plus side, integrating renewable energy in markets that we need them today. There isn't, I feel, going to be massive amounts of consolidation. There's enough elbow room in this market for multiple different technologies to serve different niches. And as a result, rather than simply technologies coming online and dominating the market, you will see a spectrum of them designed for different use cases and different durations. There's going to be massive amounts of investment in the market as well, both into R&D companies and more commercialized companies. And it's going to vary dramatically by region as well, where in renewable focused regions, you'll see big investment into proof of concepts and studies into the market in the next 5 years, and then execution in the next 10, in order to set the stage for broad decarbonization targets over the next 20 years.
Perfect. Long story short. That's great.
Long story medium, let's say.
Well, thank you. Thank you so much, everyone, for your intervention today. It's been really, really interesting. I think it's the right time to start working on long duration and getting more input about it and how it's going to develop in the following years. So I would like to thank our panelists today. Thank you so much. and also the people attending, and your questions. They're really great and they're really specific too. So that's why we're going to send them to our specialists. But thank you so much for the participation. It's great to have people from all around the world, not only the US. I'm getting to know a bit more about the subject, and we will be sending everyone the recording and the materials in a couple of days. And thank you so much. We hope to see everyone very, very soon. So everyone have a great day.